Welcome to Navakokon Education Society's DBJ College, Chiplun, the online session conducted by Shriram Dandekar. In this session, we are going to study logarithmic differentiation. Before we start this differentiation, let us revise the rules of logarithms. The first rule is log of xy is equal to log x plus log y. So whenever log of product is there, you have to add the logarithms. The second rule is log of x upon y is equal to log x minus log y. Third rule is log of x raised to n is equal to n log x. The power can be taken in the product. The next rule is log of x to the base a is equal to 1 upon x log a. This rule is called as the change of base rule. We can change the base. Also we can write this as log x to any base divided by log a to any base. And lastly, the very simple basic rules of logarithms: log of x to the base x is equal to 1 and log of 1 to any base is equal to 0. Now, you must take precaution of the following. First one, log of addition is not equal to addition of logarithms. By mistake, we use this log of xy is equal to log x plus log y, but they are not equal. Please remember this. Next one is log x into log y is also not equal to log xy. Next is log x upon log y is also not equal to log x upon y. And lastly, log x bracket raised to n is not n times log x. This is some mistake over here. Log x raised to n is not equal to n log x. Let's start solving problems using logarithm. The first problem is y equal to x square plus 3 bracket square multiplied by cube root of x cube plus 5 bracket square divided by square root of 2x square plus 1 bracket cube. Now if we want to solve this without using logarithm, then we have to first use u by v rule, then product rule, and then chain rule, etc., etc. But to solve this, we use logarithmic differentiation, which helps the differentiation process easy. First of all, take logarithms on both sides. After taking logarithms on both sides, I get log y on left hand side, right hand side log of whatever here as it is. Now I am going to rearrange this. X square plus 3 bracket square as it is, cube root of x cube plus 5 bracket square is x cube plus 5 raised to 2 by 3. Cube root means upon 3 and bracket square here, so here it is 2 by 3. And square root of 2x square plus 1 bracket cube. This bracket cube and square root, they combine together to form x bracket raised to 3 by 2. Next one, so using the rules of logarithm, I am separating them. Log x upon y is log x minus log y. Next step, log of product is addition of logarithms. Next rule I am going to apply, taking this power over here. So this becomes 2 times log of x square plus 3. Take this 2 by 3 here. 2 by 3 log x cube plus 5 minus, take this power here, 3 by 2 log x square plus 1. Now let us start differentiating. So differentiating, we get left hand side derivative of log y, with respect to x, and the right hand side is d by dx of the addition we written. Next step, derivative of log y is 1 upon y dy by dx. Now here constant taken outside, derivative of log x square plus 3. Constant 2 by 3 taken outside, derivative of log x cube plus 5. Again constant minus 3 by 2 taken outside, derivative of log 2x square plus 1. Here derivative of addition or subtraction is addition or subtraction of derivatives. This rule is applied here. Next step, 2 as it is, derivative of log bracket is 1 upon bracket, so it is 1 upon x square plus 3 into derivative of x square plus 3. Chain rule is applied. Again chain rule is applied here also. Log of bracket derivative is 1 upon bracket into derivative of bracket. And in the third step also keep this minus 3 by 2 as it is. Derivative of log bracket is 1 upon bracket into derivative of this bracket. Now in the next step we are going to take these derivatives. Derivative of x square plus 3, derivative of 3 is 0 and derivative of x square is 2. So 2 upon x square plus 3 into 2x. 2 upon 3 into x cube plus 5 into 3x square, and 3 upon 2 into 2x square plus 1 into 4x. And also in this same step I am taking this y on the right hand side, so that it becomes y multiplied by the derivative we have taken. And finally we have the answer. Dy by dx is equal to, write the original y given to us multiplied by the derivative taken, all the steps. Or you can pause this video and you can write down these steps if you want. The next problem, using the same logarithmic differentiation, we have given y is equal to square root of x minus 3 into x square plus 4 upon 3x square plus 4x plus 5. Again, to solve this without using a logarithmic differentiation is slightly tedious, and therefore I am applying logs on both sides. Taking logs, we get log of y is equal to half of log x minus 3 plus log x square plus 4 minus log 3x square plus 4x plus 5. Square root of everything. Square root means bracket raised to half. So this half is here. And remaining product is addition and division means subtraction. Take derivative. Left hand side chain rule is applied. Log y derivative is 1 upon y into dy by dx. Right hand side keep half as it is outside of the bracket. Use the derivative of log bracket concept here. 1 upon x minus 3. Derivative of x minus 3 is 1, so no need to write here. Now derivative of log x square plus 4, it is 1 upon x square plus 4 multiplied by derivative of x square plus 4. Derivative of x square is 2x, and minus derivative of log bracket is 1 upon bracket into derivative of bracket. The derivative of 3x square plus 4x plus 5 is 6x plus 4. In the next step, take y on right hand side. We get dy by dx is half y multiplied by all the terms as it is. And finally write y as given in the original problem, half into y, that is half into square root of x minus 3 into x square plus 4 upon 3x square plus 4x plus 5 multiplied by 1 upon x minus 3 plus 2x upon x square plus 4 minus 6x plus 4 upon 3x square plus 4x plus 5. Let us move to the next part to use of logarithmic differentiation is for some different type of problems also. Can you tell me what is the difference between these four? X raised to a raised to x, a raised to a, and x raised to x. Observe the base and index everywhere in all these four. Firstly, x raised to a, the base is variable and index is constant. For this, we use the derivative formula d by dx x raised to n is equal to n into x raised to n minus 1. When the base is variable and index is constant, only in that case this formula is applicable. Next one, a raised to x. Here x is variable and a is a constant, that is base is constant and index is variable. In this case we apply this formula, derivative of a raised to x is equal to a raised to x times log a. Next one is a raised to a raised to a is constant, its derivative is 0. And now when both base and index they are variable, in this case any of these three formulae cannot be used, and therefore we use logarithmic differentiation for such cases where base is variable and index is also variable. Let us solve a problem using this technique. We take the same example, differentiate x raised to x with respect to x. Everywhere we have to start with y equal to x raised to x. In textbooks many times we have given only such problems, differentiate so and so with respect to x. Always begin such problems with y is equal to the given things. Let here y equal to x raised to x. As usual, first step is taking logarithms on both sides. After taking logarithms on both sides, we get log y on left hand side, right hand side log of x raised to x, that x can be taken in product and we get log y is equal to x log x. Differentiate this with respect to x. Derivative of log y is 1 upon y dy by dx, and derivative of x log x, use the product rule. X into derivative of log x plus log x into derivative of x. It is equal to x into 1 by x plus log x into 1. Now take this y on left hand side. dy by dx is equal to y into 1 plus log x, but y is equal to x raised to x, and therefore derivative is x raised to x into 1 plus log x. Next problem, differentiate x raised to sine inverse x with respect to x. Here x is base, it is a variable, sine inverse x is also a variable thing, it is a function. Function to the power function, we use logarithmic differentiation. So first step, consider this as y. Now take logarithms on both sides. Log y is equal to sin inverse x into log x. Next step, differentiate both sides with respect to x. 1 upon y dy by dx is equal to, now derivative of product rule, sin inverse x into derivative of log x plus log x into derivative of sin inverse x. It is sin inverse x upon x plus log x upon under root 1 minus x square, and therefore dy by dx is equal to y multiplied by sin inverse x upon x plus log x upon under root 1 minus x square, and in the last step, writing y equal to x to the power sin inverse x will give us the last answer. Let us solve one more problem. Differentiate x raised to x into sin inverse square root of x with respect to x. As usual, y equal to x raised to x into sin inverse x. Remember, this is the product, and inside the product this is function to the power function, and therefore we have to use the logarithmic differentiation. Here, because I have log of xy equal to log x plus log y, that formula with me, I am going to directly write out taking logs on both sides. Taking logarithms on both sides, we get log y is equal to log of x plus log of y, that is log of x raised to x plus log of sin inverse x. Log of x raised to x becomes x log x. Now differentiate this with respect to x. Differentiate this with respect to x, we get 1 upon y dy by dx is equal to derivative of x log x plus derivative of sin inverse root x with respect to x. This is equal to x into derivative of log x is 1 by x and log x into derivative of 1. Product rule is applied for x log x, and log of sin inverse root x, chain rule, log of bracket derivative is 1 upon bracket into derivative of bracket, that is derivative of sin inverse root x is 1 upon under root 1 minus bracket square, that is root x square, into derivative of root x. Derivative of root x is 1 upon 2 root x, or half into x raised to minus half. In the next step, write this nicely and then take y on left hand side. And finally the answer is y dy by dx is equal to x raised to x sin inverse root x into 1 plus log x plus 1 upon 2 under root x minus x square outside of root sin inverse root x. Problem is differentiate x raised to tan x plus under root of x square plus 1 upon x. Firstly, call this as y. Y is equal to u plus v, I am going to assume. Remember that initially we studied there is no formula for log of x plus y. No formula for this, and therefore we cannot take directly logarithm. In the previous problem, here product was there, therefore we could take logs on both sides directly, but here taking logs directly on both sides will give you a 0. So u is x raised to tan x and v is square root of x square plus 1 upon x. I am taking this quickly because we know how to find derivative of x raised to tan x using logarithms. U is equal to x raised to tan x. Take logs. Taking logs on both sides, we get log u is equal to tan x into log x. Differentiate it and get this 1 by u du by dx is equal to tan x into derivative of log x, and therefore du by dx is equal to u into tan x upon x plus log x into sec square x, where u is equal to x raised to tan x. I have taken this quickly because you know this process very well. Now to take the derivative of square root of x square plus 1, we don't need logarithms at all. V is equal to square root of x square plus 1 upon x, that is square root of x plus 1 by x. Directly taking the derivative of square root is 1 upon 2 square root into derivative of the bracket. It is equal to 1 upon 2 under root x plus 1 by x into derivative of x is 1 and derivative of 1 by x is minus 1 upon x square. Next is make the denominator same. X square minus 1 upon x square is done, and here also the same thing is done. Now take this x square inside the square root, so it becomes x raised to 4. That x raised to 4 cancels with this x and we get x cube here, and therefore dv by dx is x square minus 1 upon 2 under root x cube into x square plus 1. And therefore as y equal to u plus v, we have dy by dx is equal to du by dx plus dv by dx. Du by dx we have found out x raised to tan x into tan x upon x plus log x into sec square x, and dv by dx we have found out x square minus 1 upon 2 under root x cube into x square plus 1. Next problem is differentiate sin x raised to tan x minus x raised to log x with respect to x. Again here subtraction of two functions, and both the functions involve function to the power function, and therefore we have to separate them as u and v and then take derivative separately and then write the answer finally. Here let y equal to sin x raised to tan x minus x raised to log x. It is equal to u minus v, so u is equal to sin x raised to tan x and v is equal to x raised to log x. Therefore y is u minus v, u is equal to sin x raised to tan x, take logarithms and we get log u is equal to log of sin x raised to tan x, this tan x over here, so it becomes tan x into log of sin x. Now differentiate both sides with respect to x and get 1 upon derivative of log u is equal to derivative of tan x into log of sin x. Use product rule for this derivative and use chain rule for this derivative. Derivative of log u is derivative of log u is 1 upon u du by dx. It is equal to derivative of product now tan x into derivative of log sin x plus log sin x into derivative of tan x. It is equal to tan x into 1 upon sin x into derivative of sin x plus log of sin x into derivative of tan x is sec square x. Therefore du by dx is equal to u into tan x into cos x upon sin x plus sec square x into log of sin x. Now tan x is sin x upon cos x, that sin x will get cancelled, cos x will get cancelled, and writing u is equal to sin x raised to tan x, we get 1 for this, and sec square x log sin x as it is, and du by dx is sin x raised to tan x multiplied by 1 plus sec square x into log of sin x. Next step, v equal to x raised to log x. Take logs on both sides. You get log v is equal to log of x raised to log x. Take this log x here in the product. So log x into log x, it is log x bracket square. Now use logarithmic differentiation. Differentiating both sides, we get 1 upon v dv by dx is equal to, now log x bracket square, the derivative using chain rule, 2 log x into d by dx of log x, and therefore dv by dx is equal to v into 2 log x upon x. V is equal to x raised to log x, and therefore the answer is dv by dx is 2 into x raised to log x multiplied by log x upon x. Now combining both these things, since y equal to u minus v, dy by dx is equal to du by dx minus dv by dx. Put the obtained values. Dy by dx is equal to sin x raised to tan x into 1 plus sec square x log sin x minus dv by dx is 2 into x raised to log x into log x divided by x. Here is the end of this problem. Now you are requested to solve the exercise in the textbook and ask me your doubts on my mobile number given in the beginning of this lecture. Thank you very much.